Hello, I'm Steve Williams, and I work for RT Logic in Colorado Springs. Thanks for joining us for this short video. If you've ever used radio frequency, RF test and measurement equipment, you know that creating realistic and dynamic test environments can be a great challenge. Engineers who develop, test, or integrate RF communications equipment for command and control or data communication applications must answer a key question. How will my system's hardware, software, and firmware actually behave under real mission conditions? At RT Logic, we've developed a means to answer this question. The T400CS channel simulator brings a live mission signal environment directly into the lab through precise hardware-in-the-loop RF signal generation. Imagine that you're testing, integrating, or developing equipment for the scenario shown here. You have an unmanned aerial vehicle transmitting data through a satellite to a mobile ground location. When you need to test the actual communication hardware, firmware, and software for this system, you can do so in a few ways. First of all, you could set up a live test to fly an aircraft, position a mobile ground station, and transmit signals actually through the satellites. Unfortunately, live tests can be very expensive, even dangerous, and you may have to wait for worst-case signal impacting weather conditions. The test may also require resources that are simply not yet available during early test stages. Secondly, you could connect the transmit and receive equipment directly together with a cable. Of course, this verifies that the equipment can communicate, but it ignores everything that impacts signals during satellite uplink and downlink operations. Your third choice, and your best decision, is to connect the channel simulator between the transmitter and the receiver. The channel simulator can add the precise signal distortions that will exist during this mission. Things like dynamic attenuation, Doppler shift, and time delay. Because the channel simulator can also add atmospheric noise, interference, and jammers, along with the effects of antenna beam shapes, terrain, weather, and multipath, the receive equipment now can see signals identical to those transmitted from the UAS and pass through the satellite down to the ground station. Here's an example of the system in action. We're transmitting digital video through one modem and having that same signal being received by the second modem. The channel simulator is electrically connected between the two modems. This demonstration gives a visual indication of how signal propagation effects impact the quality of the received video. Now, let's take a look at some of the individual contributors to overall signal distortion utilizing our embedded spectrum analyzer. The channel simulator can add effects for Doppler shift to emulate frequency and data rate changes due to relative motion, time delay to emulate the signal propagation time, attenuation to emulate path loss, weather fading, and antenna patterns, multipath fading for urban, water, or close terrain effects, additive white Gaussian noise to simulate atmospheric noise, interference to emulate accidental or intentional jamming from other signal sources, programmable filtering to emulate the phase and magnitude response of equipment in the RF path, such as satellite transponders, and finally phase noise to emulate jitter from equipment in the RF path. Because many teams use analytical graphics SDK software for modeling and simulation, RT Logic created an SDK plugin so teams could leverage their extensive modeling and simulation investments directly into hardware-in-the-loop simulation. As a scenario plays in SDK, the plugin captures simulation data directly from the SDK physics engine, commanding the channel simulator to create real-time RF signal environments that precisely match the running scenario. The SDK plugin works with any pre-existing scenario. The channel simulator can emulate almost any RF channel, whether these are part of SATCOM scenarios, aircraft missions, rocket launches, ground communications, or test range applications. The system is available in several form factors and with key specifications customized to each user's individual requirements. Bandwidths up to 250 megahertz are available, along with a wide range of frequency coverage from VHF up through Ka band. The instrument includes a simple GUI interface, a remote programming interface, and a text-based format for creating your own dynamic simulation files. If you're involved in communication system testing or training, The RT Logic Channel Simulator is an invaluable tool. It emulates conditions that are expensive, dangerous, or impossible to create in a live test environment. This saves scarce program funds, improves safety, and increases the depth and repeatability of critical tests. For a demonstration or to request more information, please contact RT Logic.